Good afternoon. We are looking at the homework that was assigned from Tuesday. Part of your homework, I'm just on those two assignments. It was page 39 was to finish this, and that's what I'm going to go over today. I'm going to look at number 3, 4, 5, and 6, and then on the other page, pages 53 to 54, numbers 19 through 24. And tomorrow we will go over numbers 19 through 24. I'm not going to work all those, but we will discuss those tomorrow and then practice this some more in class. Alright, so looking at number 3, I'm going to write it over here so you can see it. We want to graph this rational function. And we know that this is a rational function because it's in the form of a fraction. It's in the form of a fraction. I'm going to zoom in for us. Ooh, that's too much. Alright. Step 1 in order to graph this is to find the horizontal asymptote. And I told you that we can abbreviate the horizontal asymptote as HA. Okay, HA. Okay, remember, to determine the horizontal asymptote, you look at what's the highest degree in the numerator. The highest degree in the numerator is understood 1 for this exponent. Down here is 2. The degree is higher in the denominator. So your horizontal asymptote is automatically y equals 0. Remember, if the degree is higher in the numerator, there's no horizontal asymptote. None. Numerator, none. They start with an n. Okay, and the horizontal asymptote is just used to help draw the graph, okay? What we're about to look at now is determine any discontinuity in the graph, and to do that we need to factor it. Because the next step we're going to look at to see if there's a vertical asymptote or a hole. Remember, vertical asymptotes are more important to the graph than horizontal, but they're both. You need to know both of them to help graph it. Okay, x squared minus 9, I'm going to factor that. X plus 3 and x minus 3. Okay, you can tell there's 2 points of discontinuity in this particular function because if I plug negative 3 in for this, that would make that 0. If I plug 3 in, that would make it 0. So those two numbers are a problem area. Okay, because I cannot cancel any of these out, this is not removable. You have 2 vertical asymptotes. VA, you got one is x equals negative 3, and the other one is x equals 3. So you cannot cross. There's no holes in the graph. You just have several asymptotes. Alright, so I want to graph this. I'm going to zoom out for just a moment. Alright, I'm going to graph my vertical asymptotes. X equals negative 3. There's my imaginary line. X equals 3. Then y equals 0. That's going to be going across through 0. It's going to be sitting on the x-axis pretty much. Now, let's go and graph this so we can just see what our graph, so we know our general shape here. Remember, your function can never cross the vertical asymptote, but it can cross the horizontal. And that's why we graph in our graphing calculator to see if anything's crossing this horizontal asymptote. Okay, so I'm going to set this up. Remember, when I graph this, I put the numerator in parentheses, divided by. Okay, so if I look at this, guys, I see right here that it's getting close to my horizontal asymptote, but it's not coming over that x-axis. So in this point, I know that I'm not going to graph it over the horizontal asymptote. But you got to make me a chart to prove it. Alright, remember, to make a chart, you're going to choose a point to the left and right of each vertical asymptote and always include 0. So left of this would be negative 4, right's negative 2, always include 0, 2, and 4. And you plug these values back into your original function. Get 0.14. Negative 0.6. Negative 0.56. Negative 1.4. And 1.3. Okay, I'm going to graph those. We know it gets very close to the asymptote, but does not touch it. And that would be my graph for number 3. And it looks very similar to what was on my calculator screen. Alright, let's look at number 4. Number 4 off this piece of paper wants to graph this rational function. Y equals x squared plus 5x plus 4 divided by x squared minus 16. Okay? First thing I'm going to do is find my horizontal asymptote. The degrees are the same in the numerator and denominator, so what you would do is divide the leading coefficient. Leading coefficient is 1 here, leading coefficient here is 1. 1 divided by 1 is 1, so your horizontal asymptote is 1. And it's y equals on a horizontal. Okay, horizontal line is y equals. Now I'm going to factor so I can see any of the points of discontinuity, I mean by vertical asymptote or whole. That is easy. Okay, I see I have a hole here because these factors can be canceled out. So I'm going to put a hole. If I set that equal to 0, that would be x equals negative 4. Because if I plug negative 4 in, this will make 0 in the denominator, and you cannot have 0 in the denominator. It's undefined. I cannot cancel this out, so this is a vertical asymptote. So it's x equals 4. Alright, let's graph our horizontal asymptote. I'll go to y equals 1 right here. I'm going to graph my horizontal and vertical, and I'm going to come out and do my hole in just a minute. Horizontal, vertical, x equals 4. Okay, I want to graph it so I know what does it look like. Does it cross that horizontal asymptote? So I'm going to go to graph it. The original, x squared plus 5x plus 4 divided by x squared minus 16. I'm going to hit graph. If you look at this, it does not cross that horizontal asymptote, so I know that my graph is not going to cross that horizontal asymptote. So, now I'm going to make a table. Remember, you pick a point to the left and right of the vertical asymptote and always include 0. So I'm going to put 0, that's going to be left of this is 3 and 5, and that's all I'm going to need to choose for this. Now I'm going to plug that back in the original, plug 0 back in there. That's going to give me negative 0.25. Plug 3 in. gives me -4. Plug 5 in. And you get 6. Okay, I'm going to graph that. And you have a function like that. That's your sketched, your graph. Let's give it, I forgot to talk about the domain in the first one and range, but let's look at number 4, the domain. You start from the left, it's good till you get to this point right here. Right here. So that's going to be from -infinity to 4, union 4 to infinity. Range. Start from the bottom. Is it going to hit something? Yes. The way you have a problem is at 1 because nothing's touching 1 nowhere. So it's going to be from -infinity to 1, union 1 to infinity. Okay, let's look at number 5. Y equals x squared minus 4 over x plus 2. Okay, first thing I'm going to do is find my horizontal asymptote. Well, look at the degree in the numerator is 2. Degree in the denominator is 1. The degree is higher than the numerator. Numerator, none. So there is no horizontal asymptote. Now we're going to look for our points of discontinuity, and when I say that, that means vertical asymptote or a hole. Remember. Alright, so I'll need to factor this down. Y equals difference of squares, x plus 2, x minus 2 over x plus 2. Well, look here, the only thing that troubles me is x equals -2. Because if I plug -2 and that would put a 0 in the denominator, and that would make that undefined. Okay? But if you look here, I can cancel that out. So this is not a VA, so I have no vertical asymptotes. None. And my x equals -2 is a hole. So you said, Mr. Esther, what do you graph if this cancels out? Well, you're just graphing what's left, y equals x minus 2. Because if you were to graph this, this is very similar to when we did the other day in our examples. If I was to graph that, that's going to give me a linear function. That's why you have this right here. That's the linear. But the hole does not show up on here. Okay, you said, Mr. Sir, how can you prove that? Okay, go to second trace, above trace is calculate, and hit 1. I'm going to type that value for x right there, -2. When I do that, do you see there's nothing in the y spot? That means it's not defined there. So that's how you can prove it. Okay? Now, so I'm going to graph x minus, guys, we forgot to do something this other one. Number 4 right here. On number 4. Number 4. What did we forget to do here? That hole right there. X equals -4. Oh, that's a big no-no. So we're going to go back here to 1, 2, 3, 4. I need to put a hole right there to show that that is not defined there. I'm sorry about that, guys. It's not defined there. So therefore, that messes up our rate. That messes up our domain as well, doesn't it? So, your domain would be negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. I'm sorry about that, guys, but you got to put a hole there because we said hole, negative 4. And the reason I remember that is because we're talking about a hole here. Okay? Sorry about that. So, I'm going to go graph this. Slope-intercept, negative 2, up 1 over 1, up 1 over 1. Okay? Go backwards. Now my hole is going to be at negative 2, so I'm going to have an open dot there because x is negative 2. And that would be my graph of this function. Let's talk about the domain. Starting from left to right, it will come all the way to, we'll go hiccup right here. So negative infinity to negative 2, union negative 2 to infinity. Range, negative infinity till we get it to this number, 1, 2, 3, 4. Negative 4, union, because that's at negative 4, union negative 4 to infinity. Hope I didn't confuse you too much on number 4. Okay, let's look at number 6. Number 6 is a different one. I don't know if I'm going to give you anything like this, but let's still talk about it. Alright, so first thing we're going to do, find the horizontal asymptote. Degree 1 here, degree 1 here. I'm going to divide the coefficients. Y equals 4/3. Now I'm going to factor it to find other points of discontinuity. Well, what type of discontinuity is this going to be? It's not a vertical asymptote, so I put none. It is a hole at x equals 3, because I can remove that right there. When I remove that, guys, I get y equals 4/3. That's what I'm graphing. She said, Mr. Chester, that's the same as that right there. Okay, remember, you can touch a horizontal asymptote. So let's look at what this graph's going to look like if I was to graph this original. Like I said, this is kind of a weird one. I wouldn't do this to you on a major assessment. But if I was to graph this, it's pretty much where my horizontal asymptote would be at. So it's just y equals 4/3. So 4/3 is 1 1/3 right here. But remember, there's a hole at x equals 3. So you just draw this across. He's a Mr. Chester. The horizontal asymptote is there, and that, remember, I told you horizontal asymptote said you can cross it, when in fact it's touching this whole horizontal asymptote. So there's only a hole here. Now, your domain would be negative infinity all the way to 3, union 3 to infinity. And then my range would be, you remember how we just put a single number in that bracket? Well, it's just 1 1/3. That's the only value it's touching. You say, well, it's open there. All these others cancel that out. So you just put 4/3, or you can put just 1 1/3. That's the range for that particular graph. Okay. Tomorrow we're going to go. I'm not going back over these problems tomorrow, but I will go over the homework, the problems that you had to do on the other page.